In this lesson, we're going to learn about independent and dependent variables. The independent variable is referred to as x, and you can think of it as kind of standing alone. It doesn't need anything else. For example, when you see a word problem, if time is one of the variables, one of the things that changes, it will always be the independent variable because time keeps ticking no matter what else is going on. Then we have the dependent variable, which represents y, and this changes based on the independent variable. For example, when you think about the rate of change for a car in miles per hour, the number of miles you've driven depends on the hours or the amount of time you have been driving. And then there's three options for a rate of change, as we saw on a graph. We can have a rate of change that's positive. Both variables increase together, for example, miles per hour. The number of miles you drive goes up as the hours you've been driving goes up. You can have a negative rate of change where one value increases while the other decreases. So for example, your heating bill goes down as the temperature outside goes up. That would have a negative rate of change. Or you can have a rate of change that's zero. This is when the dependent variable does not change, and we'll see an example of that in our notes. Our essential question today, we're hoping to figure out the difference between the independent and the dependent variables. The first thing we're going to do is figure out which variable is independent and which variable is dependent. So when you see a word problem, you want to determine what two things are changing. Those are your variables. We have 2 pounds of apples costing $3 and 6 pounds costing $9. The two values that changed were the pounds. We went from 2 up to 6. And the money, we went from 3 up to 9. So those are the two variables. Those are the two things that are changing in this situation. What you do is you ask, does pounds depend on the amount of money you pay? Or does the amount of money you pay depend on the pounds you buy? Which sentence makes sense? The second sentence makes sense. So money is the dependent variable, and pounds, LBS is the abbreviation for pounds, is the independent variable. Second scenario, an airplane is ascending 3,000 feet in 10 minutes and 4,500 feet in 15 minutes. Which two pieces of information are changing? We have the feet and the minutes that are changing in this case. So does the number of feet we are in the air depend on how long we've been ascending? Or does the time depend on how high in the air we are? The first sentence makes sense. So the feet is our dependent variable, and minutes is time. So that is always the independent variable. And our heating bill temperature example. In January, the Johnson's heating bill was $100, and in April it was $50. So which two values changed? I see money changing. The other one is a little bit trickier to figure out, but it's time. We went from January to April, so the number of months was changing. So does the month it is depend on the money we pay for our bill? Or does our bill depend on what month it is? The second sentence makes sense. So the money is the dependent variable, and the month or time is our independent variable. Next, we'll be looking at calculating that rate of change. So we have an example with tickets for Valley Fair. $30 went up to $45, and the number of tickets went from 2 to 3. So does the money depend on the tickets we buy? Or does how many tickets we buy depend on the money we pay? The first sentence makes sense. So money is our dependent variable, and the number of tickets is our independent variable. It's important to identify that so that we can set up our rate of change. So change in dependent variable over change in independent variable is how we calculate our rate of change. So as I was writing that fraction, that little triangle represents change. So the change in the dependent variable. In our case, the change was a positive $15. The amount of money went up by $15, and then the change in the tickets went up 1 from 2 to 3. So our rate of change is $15 per ticket. And our second question was, is our rate of change positive, negative, or zero? Obviously, $15 is a positive value. Both of the variables went up together. The price went up as the number of tickets we bought went up. Looking at the late fee for a video rental, we have money and days for our variables. So does the money depend on the day, or does the day depend on the money? Money depends on how many days late it is, and days is time. So that will always be our independent variable when we have time as an option. So we're looking at change in our dependent variable over change in our independent variable. The money went from 2 to 2. There was no change. And the days went from 1 to 7, so we increased by 6 days. So we have a rate of change of $0 per day because 0 divided by 6 is 0. And we're putting those units back on our rate of change. Obviously, in this case, we got 0 for a rate of change because the money, the amount for that late fee, did not change from day to day. And our last example, we have the price changing and the days changing. Days is time, so that would be our independent variable, leaving money to be our dependent variable. So we're going to figure out the change in the dependent variable over the change in the independent variable. This one is very tricky to set up because it has this word reduced in here, which means the price paid to the builder is going down. So the change is going from losing 50 down to losing 75. So it's actually a change of negative $25 that the builder is not being paid. And the days went from 2 to 3, so there was a change of 1 day. So the builder will lose $25 per day that he does not have this house built on time, which makes our rate of change negative. The amount of money paid to the builder goes down as the days past due go up. You have 2 questions. Try to identify the independent and dependent variables as well as your rate of change.